Hello everybody, welcome to the Python Math project section. In this video, I'm going to discuss Egyptian division. So what is the meaning of Egyptian division? It is a division that uses addition and multiplication to find out the quotient and the remainder. So first we will be given a divided by b, so a is the dividend and b is the divisor, and they are both integers, and we have a larger than or equal to b. And then we start with 1 in order to get the consecutive powers of 2, and then we can put them on the first column. After that, we multiply b by 2 when we get the powers, and then we put multiples on the second column. We can stop the two processes above when the multiple of b is just smaller than a. We have a way to really check it out later on in the implementation. And then we can choose the multiples of b that can help us accumulate to a as close as possible. And after that, we can add the corresponding powers of 2 to get the quotient of a divided by b. And of course, it is possible that we have a remainder. The remainder is equal to a minus the accumulated sum. In the course of finding out the multiples of b that can help us accumulate to a as close as possible. Now, let us see an example of the Egyptian division. Suppose I want to divide 259 by 14. So a is 259 and b is 14. Then we have to create the two columns. The first column on the left is the powers of 2, and the second column is the multiples of 14, which is the divisor. So we can set up these 5 rows by just doubling the previous number in the previous row. And when will we stop the setting up of the rows? We stop the setting up if the next double of the second number is greater than a, which is the dividend. So here the second number means the multiples of the divisor. After we have stopped the building up of the rows, we can pick up the rows that can help us accumulate to the dividend as close as possible. So we can see that the last row and the second row can give us the accumulated sum that is as close as possible to 259. So you can see that the sum for now is 252. It is actually the closest possible sum that can get close to the dividend. So in this case, we just add the corresponding numbers on the first column. So we will get the quotient being 16 plus 2, which is equal to 18. So when we find out the accumulated sum, we can add the powers of 2 to get the corresponding quotient. And of course, the remainder is just equal to the dividend minus the accumulated sum. So we have 259 minus 252 to get 7 as the remainder. Now let us see the implementation in Python. So of course, I have to obtain the dividend and the divisor first. So I just use the input function to help me get the numbers, and then I turn the inputted string into the integer data type so that I can handle the two numbers directly. After that, I'm going to set up the two columns. So here the two rows are trying to set up the first value of the first column and the first value on the second column. So the first number on the first column is always 1, because we try to build up the powers of 2 starting from 1. And then the second column would start with the divisor, and then we will build the multiples of the divisor by multiplying the currently last row value by 2. So now I'm going to build up the two columns by finding out the other numbers that I have to put on the two columns. So I would like to print out the first line of the table, and after that I am able to print out the further rows of the table. Of course, I already know that the first row would have 1 on the first column and divisor on the second column. When we want to build up the table, we have to notice that the final value on the multiples list has to be at most as large as the dividend. Otherwise, we don't need to go further to build up our rows further. So we have to check this condition. So -1 here means the final element of the multiples list. That means I want to always check the final element on the right column to see whether I have to really build up the table further. If I'm pretty sure that I need to build up the lines, I have to set up the next multiple, which is equal to 2 times the last element on my multiples list column. So next multiple here will become my next number to be put on the second column. And then I have to check whether I need to put the powers of 2 on the first column. The condition is that if the next multiple is still smaller than or equal to the dividend, then I have to build up my first column. Okay, I use the POW function to build up my powers. So the base is 2. The exponent depends on the number of elements on the list called powers of 2. So LEN here means the length. So I can get the number of elements in my powers of 2 list. At the beginning, I already have one value called 1. So the length is at least 1. So when I do so, 2 to the power of 1 is 2. So we will have next power being equal to 2 when we want to build up the second row. Okay. And then we can go further by building up the consequent rows by taking care of the number of elements in my current powers of 2 column. Okay. So how can I build up the other rows? Let me show you my way first. Okay, I can just print out the next power and the next multiple as the content of my next row. After that, I really have to put the 2 numbers into the 2 lists respectively. So this is my way of putting the 2 numbers into the corresponding lists. I use the append method. So I will put the next power and the next multiple at the end of the 2 lists. So we can see that if the next multiple is no longer smaller than or equal to the dividend, it means that I don't need to build up my rows further. In this case, I can just leave the while loop and the building up will end. And then I can find out the corresponding rows that can help me add up to the quotient and the accumulated sum from now on. Okay, I set up the accumulator, which is a variable to store the accumulated sum. And of course, I have to set up my quotient because we know that the quotient is found by addition. We have to set it as 0 at the beginning. And then we have another variable called remaining dividend. Here I'm going to store the quantity that I can do further for my division. So it is actually equal to the dividend minus the accumulator. Okay, so I have a variable to really store the quantity called dividend minus accumulator to see how many more steps I can do. So let us find out the corresponding rows that can help us find out the quotient and the remainder. My idea is to find out the rows backward. That means I find out the numbers from the end of the lists that I created in the previous part. So I can use a for loop, and the range object is like this. I have to take care of the number of elements in my powers of 2 list, and the length minus 1 means that I can pick up the index of the final element of the list. And the end here is minus 1. That means I can go further to index 0 at most. Okay, and minus 1 here means I want to go backwards. Okay, so I can jump from the final index to the first index, which is equal to 0. Okay. So if the remaining dividend is larger than or equal to the number corresponding to the current index from the multiples list, then I have to do something. So here this row tries to find out the multiples list content that can help me accumulate to the dividend as close as possible. So if the remaining dividend is actually smaller than the current element in the multiples list, then I don't need to pick that multiple to become part of my accumulated sum. Okay, I can have these two rows. So the first row is trying to pick up the multiples of the divisor that can help me accumulate to the dividend as close as possible. And at the same time, I have to pick up the corresponding powers of 2 to become the quotient. So you can see that I can just accumulate the two quantities to get the accumulated sum and the quotient. And then I'm trying to print out the row that I picked up and the accumulated sum of the quotient and the partial sum. So I just pick up the row and then I print out the content of a particular row indicated by index I. Then the cumulative sum of the column 1 would become the quotient at the moment I check the current row. Of course, I can find out the partial sum by picking up the corresponding values on column 2. And then I add them together to get the sum that I can find at the moment of investigating index I. Then I can find out the remaining dividend by subtracting the current multiple that I'm investigating from the original remaining dividend. Okay. Then I can try to find out the quotient and the remainder after setting up the corresponding accumulator and the quotient. Of course, I can also print out the remaining dividend for easier understanding of the algorithm. Then I can try to print out the quotient and the remainder. Okay, I can print out the quotient and the remainder is just equal to the dividend minus the accumulator. So I can find out the remainder and then I can print it out. So let us see some examples. Save, and then I run the program. I try something like 579 divided by 19. Okay, you can see that I have set up the table like this one. So you can see that the final element on the second column is just equal to 304. Because when we multiply it further by 2, the product is actually larger than the dividend. That means I don't need to consider that row. In this case, I can start with the final row, and then I can see that, oh, the quantity here, 304, can be taken out to become part of my accumulated sum. Okay. Of course, I have to pick up the corresponding power of 2 to become my quotient. So the cumulative sum of the first column would be 16. The cumulative sum of the second column would be 304. And of course, the remaining dividend is just equal to 579 minus 304, which will be equal to 275. That means I have to see the numbers on the second column that can sum up to this quantity as close as possible. So how about trying the second last row? So we have 152. At the same time, I have to pick up the corresponding power of 2, which is equal to 8. And then the cumulative sum of the column 1 would be 24 because I add 16 and 8 together. And of course, the cumulative sum of the second column would be equal to 456, which is equal to 304 plus 152, okay? And then the remaining dividend would be equal to 275 minus 152. So I have 123 as the answer. That means I can pick up at most this quantity from my upcoming rows when I go up the table. Okay, so how about trying 76, which is the third row. Okay, so I can pick it up, and then I also pick up the corresponding power of 2, which is equal to 4, and then I can have the cumulative sum of column 1 as 28, and I can get the cumulative sum of the second column as 552. In this case, the remaining dividend that I can go further is just equal to 47. So I can try the next row, which is 38, and then I pick up the corresponding power of 2 to become my quotient. So the cumulative sum of the first column would be 30, and the cumulative sum of the second column would be 570. So you can see that I have only 9 remaining to pick up. But is it possible for me to go up the table further? It is not possible, because when I have picked up this row, when I go further, I can only pick up at most 9, but the next row up is 19. That means I have to stop at the second row here, and I cannot go further because this remaining number is smaller than this current number. Okay, so in this case I have to stop the addition. So the quotient is equal to the cumulative sum in column 1, and the remainder is just equal to the dividend minus the cumulative sum on the second column. So the remainder is equal to the dividend minus the cumulative sum on the second column. That's why I have 9 as the remainder. So how about trying another example? Let's see. 265, 13. So I have these rows coming up. And of course I can pick up the final row, because the final row gives me a multiple of the divisor which is smaller than the dividend. Okay, so I pick up the corresponding power of 2 as well. After that I have 57 remaining to pick up. Of course in this case I'm not able to pick up the second to last row because this number is actually larger than the remaining dividend. So how about trying further? Yes, I can go further by 1 more row to pick up 52, because 52 is still smaller than the remaining dividend. That's why I can pick up 52. And the cumulative sum of the first column would become 20, and the cumulative sum of the second column would become 260. Okay, so the remaining dividend is now 5. So you can see that I cannot go further because those multiples of the divisor is actually larger than 5. So I cannot go further to pick up other rows. In this case, I have to stop at the third row. Okay, so the quotient is just equal to 16 plus 4, which is 20, and the remainder is equal to the dividend minus the accumulated sum in column 2, which is 260. That's why I have 5 as the remainder. So this video has already talked about the way to do Egyptian division. We have to set up the rows so that the final multiple of the divisor is smaller than or equal to the dividend. Okay. And then after I've set up the table, I can try to find out the corresponding multiple of the divisor that can sum up to the dividend as close as possible. At the same time, I accumulate the corresponding power of 2 to get the quotient. And after that, I can print out the quotient and the remainder. And of course, I have to find out the remaining dividend to see how much I can go further to pick up the multiple of the divisor. And finally, I can print out the quotient as well as the remainder, which is equal to the dividend minus the accumulated sum on the second column. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.